you know what are the scalar quantities and what are the vector quantities. The mathematical quantities, those are used to describe the motion of an object, can be divided into two categories like scalar quantity and vector quantity. So here first of all I am going to discuss scalar quantity. A scalar quantity is any physical quantity that can be identified by number 1, a number which tells the magnitude of the quantity. Number 2 is an appropriate unit. Scalar quantity can be added, subtracted, multiplied and divided by common algebraic rules. Such examples are 2-meter distance between girl and boy, 50 kg mass, 37 degrees centigrade temperature of any object, energy and many more. And on other hand is vector quantity. Vector quantity is any physical quantity that can be identified by number 1, a number which tells the magnitude of the quantity. Number 2, an appropriate unit. Number 3, a specific direction. This means the vector have both magnitude and direction. For example, displacement, velocity, acceleration, and many more. Imagine yourself calling for pizza delivery. Then the pizza owner asks you, where do you live? Then you reply 50 meters from your store. Here the 50 meter is a vector quantity and only 50 meter is a scalar quantity. Now let's talk about the motion along a straight line, distance and displacement. The basic form of motion is the motion along a straight line. There are many parameters to consider in this kind of motion, but we will only investigate the fundamentals, which are the distance and displacement. Let us begin learning motion in a straight line by this common example. Imagine your friend Susie standing outside her house. This is her original position, 100 meters is away, where the convenience store located. Between Susie's house and a convenience store, there is an internet cafe. It is 50 meters away from Susie's house. Susie is having a walk going to the convenience store. She will pass across the internet cafe until she will reach the convenience store. During the process, she will cover 50 meters from her house to the internet cafe, another 50 meters until she reach convenience store, a total of 100 meters. When Susie finished her business in the convenience store, she decided to go home. She will pass again the internet cafe until she reach her house. The length of a turn journey will be 50 meters to reach the internet cafe and another 50 meters to reach her house. So if you look at the total path length from her house, the convenience store, she traveled 100 meters going home. When she reaches the internet cafe, it will be 100 meters plus 50 meters, which is equal to 150 meters. And when she is back to house, it will be 150 meter plus 50 meter equal to 200 meter. This path length is basically the length of the path, and it is also known as a distance. Take note, distance is only representative of the magnitude of the path traveled in meters. It is only a quantity without a direction. Hence, distance is a scalar quantity. Here is a new term, that is displacement. It is a vector quantity. It is the shortest distance traveled between initial and final point of traveling object. The SI unit of displacement is also meter. Going back to examples, we saw how Susie traveled from house to internet cafe and going back to house. We previously looked the distance values, but now we look at displacement values as Susie went to store. The distance and displacement are equal, but here we talk about the direction that Susie covers 100 meters towards the store. It means here we are indicating both magnitude and direction. So in other terms, we are talking about the displacement. This is the whole about the distance and displacement. Some bodies move fast while others slow. In order to have comparison between fast and slow moving bodies, we have to define a new physical quantity known as speed. The speed is the ratio of the distance traveled by the body to the time taken for the travel. We define average speed as the total distance s traveled during a particular time divided by a time interval t. So mathematically, we can define as the distance traveled per unit time, or we can say the rate of change of distance is known as speed, or we can also say that distance change with respect to time is known as speed. Dear students, here you know that distance is a scalar quantity. So here a scalar change with respect to time, we will get a new scalar quantity, that is speed. So speed is also a scalar quantity. The SI unit of speed is meter per seconds. Speed refers only to the time rate at which a body is moving, whereas velocity refers to the both speed and direction. It means velocity refers both magnitude and direction in which the body is moving. The velocity can be defined as the rate of change of displacement or the distance covered by the body in a definite direction. Here if we talk about the direction, it means the speed is a vector quantity. So according to the definition of vector, velocity have both magnitude and direction. The mathematical formula of velocity is displacement upon time, or we can say displacement change with respect to time, or s upon t. The SI unit of velocity is also same as speed, that is meter per second. Now let's move to the last topic, that is acceleration. Acceleration is also a vector quantity. It can be defined as the rate of change of velocity with respect to time is known as acceleration, or the velocity change with respect to time is known as acceleration. The SI unit of acceleration is meter per second square. Dear students, I hope today's topic is clear to you. Inshallah, we will meet into next lecture. Till then, take care of yourself. Allah Hafiz.